Alright guys, so like we said, when we are solving for x, we need to take our equation and just multiply both sides. So if we have our number 1, the square root of 5 plus 20x, and that equals x plus 4. So the opposite of the square root is the square. So we're going to square both sides, which means we can just say that 5 plus 20x is my left side. And over here off to the side again, we're going to have x plus 4 times x plus 4. So that is x squared, 4x, 16. So x squared plus 8x plus 16. Now that we've got all of our terms, we need to put them all on one side so that we can actually factor. So I'm going to subtract 5 and 20x. So I can have 0 equals x squared minus 12x, and then 16 and negative 5 is 11. I can factor 11 into 1 times 11, and if both of them are negative, negative 1 times negative 11 is positive 11. Negative 1 minus 11 is negative 12. So these are my two factors. I have x minus 1 and x minus 11. To make my factors into solutions, again, I need to just recognize that this equals 0. So I have x minus 1 equals 0 and x minus 11 equals 0. Add 11, add 1, so x equals 1, x equals 11. Some of you are getting good enough now, you just could do this in your head, flip the sign, x minus 1 becomes x equals positive 1, x minus 11 becomes x equals positive 11. Let's look at our answer choices. Alright, negative 11 is not true, negative 1 is not true, 1 and 11 are true. So we know 3 and 4 is going to work for us here, and that's going to be option A. Alright, number 2 says the function g is a translation that is 3 units right and 5 units up from this function. So let's start with f of x, and then we're going to shift 3 units right and 5 units up. Alright, so f of x is the square roots of x plus 5. And they want us to go 3 units right and then 5 units up. So we want to go right. We're going to come out here 1, 2, 3. That's a positive 3. And remember that when I'm working with inside of my x grouping, I need to use not the positive 3 but the opposite sign. So over here, we'll have g of x equals the square root, and then here's my x plus 5. Now instead of writing it like you see the x over here, we're going to have to say x. We need to go 3 units right. So I'm thinking plus 3, and I'm going to have to flip my sign to minus 3. Now the last thing they want me to do is go 5 units up, which means that I need to put a plus 5 out here on the end. X minus 3 plus 5 will simplify for me into x plus 2. And you're still going to have this plus 5 out here to the side. So that for us will be the option J. Alright, on number 3, they say if x is a positive number, then the fifth root of x plus x to the 1/5 is what? Well, x is a positive number. Let's just call it 1 for now. So if I wanted to manipulate these functions, I could see that this is this fifth root of x divided by x to the 1/5. Another way to write this, the fifth root, is just x to the 1/5 over x to the 1/5. No matter what number x is, if x is 1, if x is 2, if x is 3, it will still be something divided by itself, which will always be 1. So knowing that fact will allow us to select B as our final option. On number 4, they give us the distance a pilot can see to the horizon depends on the altitude of the plane. In other words, the higher up in the sky that you go, the further that you can see out into the horizon. Okay. The table shows the altitudes and the distance you can see to the horizon. Use a graphing calculator to find a square root function to model the data. So let's find a square root function that will actually model this data for us. So the first thing we want to do here is just set up our window. We're going to go to a new document, and we're going to need to add in a list in a spreadsheet. Remember at the very top that you're going to have your x and your y variables, and then we'll go ahead and just fill in this chart. Alright, now we've got all of our data in, it's time to run our square root regression. So we need to go to Menu, Statistics, Stat Calculations, and now we're in our regression window. We're going to go down and we're going to hit our square root regression. We know that our x and our y are what we call our x and our y variables. They can save it into graph of F1, that's fine, and we're going to put our column C. We go down to the bottom, we can hit OK, and then it'll run a regression for us. So it's going to give us ax to the power of b. So this is y equals ax to the power of b is the template that they give us. Our A is 1.223. And our B is 0.5. And another way to write 0.5 is just 1/2. So if we wanted to say y equals the 1.223 square roots of x. We can evaluate this function for where they ask us at 25,000 feet. So when y is 25,000 feet, what will x be? It says our altitude is in x. So then we can just substitute 25,000 into our x variable. So y equals 1.223 times 25,000 to the 1/2 power. We can approach this problem a couple of different ways. What I can do is go to Document, Insert a Calculator. It knows that my graph is F1, my function is F1. So I can say 1.223 times 25,000 to the 1/2. It's going to give us 193.373 miles. We look over here, it says round your answer to the nearest tenth, and I think 193 is going to get us there. On number 5, they ask us to solve the equation x equals x minus 1 to the 3/3 power equals the cube roots of x plus 1. So we go from here, And we need to try to clean this problem up a little bit. There's a lot going on. So x minus 1 to the 2/3 power looks good, but this other side still has a radical. So we're going to take care of that first. We're going to write what's under the radical first, x plus 1 radicand. Now, instead of writing the radical with a 3 in the bottom, we're going to write a fraction with a 3 in the bottom. And this means the same thing. X plus 1 to the 1/3 power is the same thing as the cube roots of x plus 1. Now from over here, one thing that might be an easy strategy for me to do is maybe just multiply this equation, raise it to the 3/1 power. Now if I raise this to the 3/1 power, it's going to be me multiplying 1/3 times 3. And this will simplify down to just 1. So my exponent is 1 over here. But if I do it to one side, I got to do it to the other. So I'm going to raise this side to the 3rd power as well. And I get to multiply my exponents. And look what's going to happen. I have a 3 in the numerator and a 3 in the denominator. So that will simplify to 1. And now this side will just have x minus 1 squared as the exponent. So left side, x minus 1 squared. Right side, x plus 1 to the 1st power. So just x plus 1. From here, we know that we can use an array to help us. This is going to give us x squared minus x plus 1. So the left-hand side of my equation will be x squared minus 2x plus 1, and then we'll have x plus 1. From here, it's just the same exact problem as the last time. We need to go ahead and subtract on both sides. Minus x minus 1 minus x minus 1. This is going to give us x squared minus 3x plus 0. All right. So on this side, I can factor out what they have in common is an x. So I put my x over here. And now I'm going to have x minus 3. Let's make sure we did this right. X times x is x squared. X times negative 3 is negative 3x. All that looks good. So now I have x equals 0, and x minus 3 equals 0. So we add 3 to both sides. And look at that. That's our answer. X equals 0, x equals 3. Those are both of our solutions. So we can come back up here, we look at our answers, and there it is. The one last thing that I like to do is just check and make sure that this is going to be all right. If I put a 0 in here, this is going to be negative 1 to the 2/3 power, and this is going to be a 0. So this is the cube roots of 1. So it has to equal 1. As long as these are mathematically possible when you substitute it back in, then your final answer will stay the same. This should be fine. Okay. Number 6 is talking about the speed of a tsunami, which is a very large tidal wave. And we've talked a lot about waves in this class now. We've started to talk about sine waves and cosine waves. So we're talking about this giant tsunami that's rushing towards land here. It's traveling with this function. This is how fast it's going. S is the speed in miles per hour. That the tsunami is traveling is D is the depth of the wave. In other words, how deep the wave is going to go. All right, so from top to bottom, this would be like 500 feet. Find the average speed when the depth is 500 feet. Great. So we're going to take our original function, s equals the square root of 200 times the depth. And we're going to substitute in 200 times 500. All right, 2 times 5 is 10, and then 0, 0, 0, 0. So this is 10,000 altogether. I would assume, this is telling us, again, that we have an average depth of 500 feet. So I can go to my graph. I can say S equals the square root of 200 G. So I type it in my calculator, it'll turn into 200x, hit enter. And we know that we're looking for this function, where x equals 500. One thing that I can do is just insert a calculator. And we're going to say that 500 is what we're calling x. And our equation was the square root of 200x. So if x equals 500, and we are looking for what is the square root of 200 times x, then we can hit enter, and it's going to give us 316.228, 316.228, and that will be the average speed, s equals, so speed equals, and they are talking speed is miles per hour. So this is 316 miles per hour. That is a fast wave coming at you, 316 miles an hour. Find the average depth of the tsunami when the recorded speed of the wave is 250 miles an hour. So when your speed is 250 miles an hour, what will your depth be? Alright, so now we're solving for the variable d, not the variable s, which means we need to undo the square root. The opposite of a square root is going to be a square. When we do that, we're left with 200. D equals 250 squared. 250 times 250 is 62,500. And now last step, we can divide by this 200. And our depth of our wave is going to be this 62,500 divided by our 250 miles per hour, which was our speed. Alright, so 625 over 2 is what this will simplify down to. And when you get to your calculator and it gives you your answer, sometimes it doesn't actually give you what you want, so you can go and have it approximate to a decimal for you. And there it is, 312.500 is your depth. And that depth is measured, it says, in feet. Alright, so this is 300 feet. Alright, so where have we come so far? We've learned that when the tsunami is 500 feet tall, it's traveling 316 miles an hour. And when the tsunami is 312 feet tall, it's traveling 250 miles an hour. Assume the function goes from 0 to 2,000 in terms of depth. What is the range? So we're looking at the y-axis, which for here stands for speed in miles per hour. So again, let's go back to our graph where we were just at. There's our function. And we are trying to restrict the domain just between the 0 and the 2,000. So let's go to menu and let's mess with our window. Our window, go into the top option, window settings. And again, you know that the depth has to be between 0 and 2,000. Okay, so a little pro tip here. When you go in, you put in your range 0 to 2,000. Leave a little space on both sides of the range so you can actually see it on your graph. So instead of 0, I'm going to put -10. And instead of 2,000, or I guess -100, instead of 2,000, I'm going to bet 2,100. So it's going to be a plus 100 on either side. Now when we're ready, we know these y values are no good anyways. We know some of our y values were 312. Excuse me, 250, 500 miles per hour, 316. So somewhere between 250 and 316 miles an hour. Probably the wave would be a minimum of 0 and a maximum. We know that, yeah, it's going to go above 300 miles an hour. So I don't know, maybe 700, 900 miles an hour. We'll see. Is like a good range, an estimate of that range. Let's come down. Let's just get a good picture of what we're seeing. Good. So we go out to 2,100. We go down to -100. So I need just this piece, the y-intercept, and then once we get here to 2,100. All right. to 2,000, excuse me. All right. So I can calculate this point right here, where x equals 0. What will y be? So I push Control T. I bring up my menu. Alright. So I do see a coordinate point here of 0, 0. So that's good to know. When x is 0, y is 0. So if they give me an x value of 0, I know that my range will also be 0. And this is your speed, 0 miles per hour. That makes sense to me. When there's no depth of the wave, it's not moving. That's a good thing. Now, when the thing is 2,000 feet deep, that's going to be a pretty fast wave. That's a pretty darn fast wave, because over here, we were only 300 feet deep, and we were already moving 250 miles an hour. So 300 feet deep, now we're going to 2,000 feet deep. 2,000 feet deep was the one that's right out here, at 2,000, where x is 2,000. So to find that x is 2,000, I'm going to go back up here, and I'm going to say again, like 2,000, and I'm going to store that as my x variable. Then I want to just make sure I've got my function. It was the square root of 200 times the x variable. So now when x is 2,000, what will y be? 632 miles per hour. So 632.456. Like that. All right. Now we've got, with this domain, our function looked like this. And we went here to 0 out to 2,000 on the depth. And speed, we went from 0 all the way up to 632.456. You know? Alright, last page. We're going to simplify these expressions. This is the square root of 16, which is 4. I still got my 3 on the top. 4 times 4 is 16. 16 times 4 is 64. Over here, we need to do some conversion underneath the radical. Alright, if I have a cube root, this means that I need 3 identical factors for that factor to be able to leave. So 8, I'm going to break that down into 2 times 4, which is 2 times 2 times 2. So 2 times 2 is 4, 4 times 2 is 8. So there's my 8. Now I'm going to have x cubed. X cubed is just x times x times x. I'm going to have y to the 5th. So y, 2, 3, 4, 5. And then z to the 7. So 1, 2, 3, 4, 5, 6, 7. All right, like we said, 3 at a time can come out. So I have 3 of these 2's. This factor will show up in my answer. Now I have 3 of these. That's a match with my root. So this comes out. I have 3 of these. So this comes out. I have 3 of these. So this comes out. And 3 of these. So this comes out. Now let's get all of my spare pieces together. I have 2 of these y's and 1 of these z's over here. They're all underneath the cube radical. So here are my 2 of these y's and 1 of my z's. Now let's clean up our coefficient and write our final answer. We can say 2 times x is 2x times y. Z times z is z squared. Now we'll have the cube root of y squared times z. When we look at our square root function, it's just a parabola on its side. It asks us for domain and for range. My domain starts at 0. and on the x-axis, it starts at 0 and goes all the way out with this arrow marking. All the way out to positive infinity. On the range side, the very smallest y value we could have is -2. And the very biggest y value you could have, I'm assuming, is as we keep going out here further and further and further, we can assume that this is just going to keep going up as well. So we can say also to positive infinity. On the same coordinate plane, if we needed to graph the square root of x, we're going to have this one here and this one here, and 2, 4 will also be a coordinate point. And this works because the square root of 4 is 2. The square root of 1 is 1, and the square root of 0 is 0. So we're going to start right here, and that's how we graph our function with that domain. Describe the transformation from f to c, where we can see that it's actually been shifted up 2 units. So we're talking about g. So this is down 2 units. If we're going to label our parent function f of x, they're asking me about g of x. Okay. So I'm going to go down 2 units, and I need to write an equation for this second one. So it's going to be y equals the square root of x, and then we need to shift it down 2 units. So we're going down 2. The very last one asks us to just solve each equation. You got to check for extra solutions. Some of them may or may not be mathematically possible. So we have 2x to the 1/2 plus 3 equals 9. I subtract 3 from both sides. I get 2x to the 1/2 equals 6. Now, if I'm going to have power to the 1/2 over here, I can square it to simplify this to 1. So this is 2x to the first power. Then over here I have 6 squared, which is 36, dividing by 2. Will get you final answer 18. And then part B. Part B has a square root on one side. So the opposite of a square root is the square. When we square a square root, we're going to get left with just what's underneath the radical, radicand, and then we have n plus 2 squared. This over here we can just expand out. This is n plus 2 and n plus 2. This will give me n squared, 2n, 2n, 4, which will give me n squared plus 4n plus 4 equals 2n plus 3. Now we're ready to solve for zeros. Now we're ready to say that this side equals 0. Great. We can get here by saying that 1 times 1 is 1. And if we add or n, I guess n plus 1 times n plus 1. We should get this one back. So let's make sure we got this right. N times n is n squared plus n is 2n, and then 1 times 1 is 1. So this looks good. So then n equals -1. All right, let's make sure that this can be true for us. If we say that n equals -1, we're going to have -1 plus 2. -1 plus 2 is 1. Over here, if we have -1, we're going to have -2 plus 3. -2 plus 3 is still 1. So the square root of 1 is 1. So that makes this true. All together, your final answer. This is your solution. N equals -1, and then x equals 2. Thank you, guys. Good luck on your quiz studies, and we'll see you next week.